I'm definitely feeling the pressure. That was very odd. I am, most of the time, I'm a developer advocate with IBM. And that means that I get to do a bunch of different things. My background's in engineering. I still write quite a lot of code, but I do also spend time coming to conferences and talking about the technologies that excite me most, which is cool because I get to choose. It's like, oh yeah, IBM pay you, so you have to talk about things that are on IBM's cloud. Luckily, we have a winning selection of open source databases, and this is absolutely no problem at all. So earlier, Gary was like, okay, I'm an advocate for PHP Storm. Who uses PHP Storm? And half the room put their hands up. I'm not going to do that. But as long as you learned today that IBM has a cloud, you can run your PHP there, and it's marvelous. I've done my job, and anything else that good comes of this session is a bonus. So I am talking today about CouchDB, PouchDB, and offline tolerant apps. So I am super excited about databases. So I started off like wildly excited by how amazing CouchDB is. But actually, CouchDB is also part of a set of tools which are really enabling applications that can work well even when things are not great. So you may have heard of offline first or progressive web apps. These technologies enable that. I've taken a quote from offlinefirst.org. Offline capability is a key characteristic of modern progressive web applications, right? When you go offline, that is expected. Yes, we are building wonderful offline apps that enable us to deliver healthcare in Africa where there is no connection. True, 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 true. These technologies are relevant for that. We're also using it to deliver applications which work on the train. Where I live, in Northern England, we have hills and tunnels. The data connection is not very good. I know which of my applications will work when I'm on that train line and which ones will not. So these are the ones, the progressive web apps. These are the apps that fail gracefully when there's no network connection. How does that even work? Well, typically what you do, this is you. Typically what you do is you use a completely client-side application. I know, JavaScript at a PHP conference. Sorry, not sorry? So you use a completely server-side application, and that is client-side JavaScript, but also client-side storage. So you're going to use a database that is in your browser, and the user is going to interact with this very local thing. For the user, this is brilliant, because all their interactions are local. All we're focused on is the user having this great experience with the device they're actually using. In the event that we are connected, which could happen, then we sync to the cloud. So when the connection is present, that data gets synchronized with the cloud. And it's two-way sync. I'll talk a bit more about what to do when things have been edited in both directions. But that's the basic idea, that you can create applications that will work even when the user has gone somewhere where their data package doesn't work, even when the local mobile phone cell tower is not working, even when you have run out of data, or even when you come to a hotel where the Wi-Fi connection is terrible. I don't know why, because I understand you have pretty good internet connection for the most part around here, just not actually here, as far as I can tell. So the technologies that I'm going to talk about in database terms, one is PouchDB, so that is a document database, JavaScript thing, lives in your browser, works in even quite old browsers, like not all the browsers on the planet, but a really good percentage of them. And also, it's called PouchDB because it's compatible with CouchDB, and that's what happens if you let geeks name things. And I'm also going to talk quite a lot about CouchDB. CouchDB is an open source document database. It's a NoSQL database. I think it's awesome, so I'm going to show you around. Let's start with an example of that offline first technology. For this, I've built a very simple shopping list app. Now, what's really impressive about my shopping list app is not the app, is that a very server-side programmer with no front-end experience at all was able to build this. It is very, very approachable. So what I've got is I've got that rich client-side application, and I've got PouchDB running in my browser. It works completely locally. If we have a connection to our shared CouchDB, our server-side database, then it'll sync. And if we don't have a connection, we won't. If you want to play with this, the code is here on GitHub. You should be able to grab it and run it. Super easy. So for this demo, I am thankfully not relying on the internet connection. I'm running CouchDB on my laptop. So I'm going to run the shopping list in a browser, and you're going to see it connect to CouchDB. What I'm actually going to do is I'm going to run a shopping list in 2 browsers, because that one is Firefox, and this one is Chrome, and they have their own local storage. So this is to imagine you use 2 different devices on the train while you're offline. That's what we're experiencing here. I can't tell if CouchDB is running or not. Let's see if it is. I think it is. It's just I've squashed my screen so much. Well, let's see anyway. If it doesn't work, it's not running. So things I need to remember to buy, put things on the shopping list. Is working. Good, fine. You put things on the shopping list in one place, and they appear in the other place. So we need to buy bread, and we need to buy milk. It's fine. Maybe I don't need to buy bread. We can delete it in the other one. It disappears in both. So you get this idea that it looks very synchronized, but what's actually happening is every app is local, and they talk to a central server. Great. Now imagine something's gone wrong on the internet. I have no idea how to find the thing that normally is here. No, I want to kill Apache CouchDB, which is normally an icon here, but my screen is now so squashed for the projector that I can't see it. I need to right-click on a thing that is no longer visible. There's more things visible here, but still not any of the things that I need. OK, well, we'll just kill it from terminal. It's fine. This is not totally the effect I was aiming for, but let's just assume it's fine. Oh, it restarts itself. Yes, of course it does. Apache. How frustrating. All right, hang on a second. I'm just going to use it as a separate display so I get my laptop back. There's CouchDB. Kill CouchDB. Better, right. Sure, we can get to do this again in a minute. All right, so CouchDB now not working. This demo used to be right at the end of the talk, so that I couldn't completely derail everything really early. Like if there was any fail, it was right at the end of the talk. But I think it's the best bit, so I put it right at the start. Now we're failing really early. What does it say? Fail fast? Yeah. All right. So now I think we're offline. Offline in the sense that we can't connect to the server-side database. So now we're going to add some stuff to the list. And it is indeed not linking. We've got some pretty healthy stuff going on over here. Feel like we've overdone the healthy stuff. All good. Let's delete some stuff. Yeah, cool. So I've got things added and deleted on both sides. I've made changes on both devices on the train while we were offline. Now let's go back online. So our connection comes back. CouchDB likes to open me a tab, which is no use at this resolution at all. And you see it start to sync. So Chrome is always faster. Firefox will get there in a minute. So the idea, I don't really know why. The PouchDB implementations are slightly different for the different browsers. Chrome is pretty reliable. Firefox will get there. So what we've got here is a situation where you can make any changes you want. It did make it, hooray. And you can make changes on both sides of databases that are split. And when you reconnect, we then resynchronize, and we can synchronize in all of the directions. Because obviously there's 3 databases at play here, the 2 in the browsers and the one on the other side. So this kind of functionality is what we're looking for with this idea of offline tolerant or offline first applications. Applications that work by themselves and then which communicate. I also pointed out that as a server-side PHP developer, this wasn't that hard to build. So all I've got in index.html, and if you look at the GitHub project, it's literally like some index.html. I've copied some layout from somewhere. I've got PouchDB as a dependency, And I've got shopping.js, which is where all my code is. Now you can easily imagine what this code does, right? If you type in the text box, it saves it to the database and redraws the list. If you delete something, it adds to the database and it removes from the database, sorry, and redraws the list. It also has this code. So this is the JavaScript code that lives on the server side and makes this all work for the database synchronization. I'm creating two PouchDB objects. The first one is the one that's in the browser. That second one, RemoteDB on line 2, that is the remote server that I'm going to connect to. Not very remote because it's on localhost, but it works for the purposes of the demo, and you could synchronize to a server and try this off multiple devices. I just couldn't figure out how to put it all on a projector at once. When the page is finished loading, we take that local database and we set up some sync. So we say sync to the remote database, live, meaning sync all of the time, keep on syncing, and retry yes. If the connection goes away, just keep on trying. When it comes back, pick it up again. Keep on synchronizing. Then I've got two callbacks. One is on change and one is on active. When there's a change arrives over that synchronization, react, which is the change arrived, just redraw the list. And when we go active, which means we just reconnected, again, redraw the list. So the database changes are coming in, and this is us reacting to them. It's a whole 13 lines of JavaScript. And I think it's something that we can all follow. If you look at my Twitter account, I've linked to the slides for this talk already. So if you want to get them to look at, that would be fine. OK. So I also want to talk in more detail about what you can do with CouchDB. In the shopping list example, we're using PouchDB. It's really just CRUD, right? We're just storing stuff, deleting stuff, and pulling a list. There's a little bit more to it, and let's start by talking about what NoSQL actually means. So in NoSQL, the reason that a lot of people don't really understand what it means is because it's not a very precise term. We call it an umbrella term because it covers many things. It could be anything. It could be the key value stores. It could be some search implementations. It means graph databases, but it also means document databases. CouchDB is a document database, so it's in the middle here, highlighted, alongside MongoDB and RethinkDB. If you've used either of those, we've got some very familiar concepts coming here in CouchDB. Now, CouchDB is used as a backend for a bunch of PHP applications. We don't really have a library for it. We have some older ones. I am working on a new one. I'd like some testers for that, so if you want to adopt this, talk to me. Let's try out some code together. Otherwise, just make calls with Guzzle or whatever your favorite HTTP client is. Guzzle has made talking to CouchDB very easy. And I have some blog examples if you're interested. So, CouchDB, it is a document database. And the idea of a document database is that instead of deciding before you start how your data will be structured and designing tables and columns, everything has to be a row fitting in those columns. You can't change your mind. Or if you do, you need downtime to make table structure changes. The document databases are schemaless, which in theory means that every record is a document. It can contain keys and values, like you would have columns with values. It can contain nested values, which can be quite useful. But each one of those documents, in theory, can be very different from every other document in the database. Raise your hand if that sounds horrifying. Yeah. So, spoiler, the documents are not all that different from each other because you're going to read and write them with the same piece of code. If they looked nothing alike, this would be chaos, right? You have a problem if all of your documents in your document database genuinely look completely different from each other. They are typically going to have all the same fields. You know, there might be fields that are there or not there, but you can just check. Does this one have some categories associated with it? Does this one have a color? It'll be there or not there, but you usually won't have radically different fields. So if you need that, if you need documents that look really different from each other, if you're working with e-commerce and you have a product database, but some things come in sizes and some things come in milliwatt hours and some things come in amps and some things come in horsepower, then it's really hard to put all those things in the same database. Magento uses the EAV pattern. It's probably the best way to solve it in a relational database. The document databases are designed for this. The other place that I see it often in PHP is content management systems, where you need to represent different types of content and widgets. So like, this is an image, it's got a source and some alt text and some dimensions. Like, this is a heading, it doesn't need dimensions, right? I often see that kind of pattern in document databases. The other place that I see it is people who don't know what their data structure should be yet, startups. So you can just iterate really quickly, and as you change your mind, you write code that tolerates either structure and just stick some more fields in the database, and it's all good. And that's ideal, particularly if you don't have, like, if you're a website that is local to a particular company or time zone, you can do maintenance at 4 a.m. If that's not how you work, then you can't. And this can be super helpful. One thing which I think we don't talk about enough with document databases is how high availability they are. CouchDB can just replicate to a bunch of different places forever, so there will always be somewhere to talk to. And they're designed with this in mind, rather than I'm a database, I'm going to be a big database, and I will try and send my updates to another big database, right? They're intended to be gregarious, and they have always been. So CouchDB specifically, I love CouchDB. I've worked with a couple of the different document databases, and I really like CouchDB. Its acronym stands for Cluster of Unreliable Commodity Hardware. It was built in a time where you took thrown out computers from a company that went bust, put them in somebody's data center. None of these machines matched. The disks were different ages. One of them was probably going to fail. And CouchDB was intended to run successfully in that situation, where you had thrown a couple of machines into a couple of different data centers. It has an HTTP API. You can talk to your database from curl. It's not to say that you want to. I'm about to, but that might not be your thing. But what is important is that every programming language and technology stack around has an HTTP client. You won't get crippled by somebody else's drivers updating and you have to wait for them to update, or you can't upgrade to PHP because the MongoDB driver failed. Like, I don't know how many Mongo users here got bitten by that, but it was a big thing. You don't have that because you just make HTTP calls. Every programming language on the planet supports that. It uses JSON data regardless of what your background is. JSON's a reality on the web. It is familiar to us in PHP. It's easy to work with, so that's brilliant. It performs very well. The document databases, you sort of expect that they shouldn't perform really well because we understand about relational databases and indexes and performance, and everything should be well planned and clean and tidy, and then you can find things in a hurry. CouchDB has its own views, and it stores the results of those views a bit like indexes, which makes them surprisingly fast to access. And I'm going to walk through some of the MapReduce stuff, which makes aggregate calculations really quick too. We also have some ad hoc queries, which you can do. It's not quite as trivial as I'm just going to write this SQL statement and run it now, but there are some tools similar to that, which you can use for CouchDB. Talking of tools, raise your hand if you love curl. Yes, me too, yeah. There are some other really good HTTP clients around, but curl is installed everywhere, and I've been doing this long enough that my fingers have typed the curl command before I've remembered there were other options. If you are a curl lover and you're going to work with CouchDB or any JSON APIs, then you should immediately get to know this tool JQ, which will make your JSON printed for humans. If you are not a curl lover, I think that's quite normal, actually. So for the command line, try HTTP console. And if you prefer a GUI tool, then try Postman. It used to be a Chrome plugin, but now it's a standalone application and it's cross-platform. I think it's one of the Electron apps. Last time I gave this talk, an enormous number of people tweeted at me about their favorite HTTP tool, and I couldn't get them all on the screen. And this morning, Gary showed you the one that's built into PHP Storm, which I did not even know. So look in this blog post, and there is bound to be a tool there that you will like, because I collected them from everybody's tweets. So let's have a little look about how that works, and how we talk to... Just escape with the fact that I killed something. Brilliant. Right. Let's have a look at how we talk to CouchDB. So you can literally just make a curl request, and it'll say, hi, I'm CouchDB. I'm Apache Software Foundation. I'm running 2.0.0, which is what we have packaged for Mac at the moment. 2.1.0 is now out. There's not a huge amount of difference. So what databases do I have lying around? Well, I'd like to see a list of all the databases. This is what's kicking about on my local CouchDB server. It's not very pretty to read, and I mentioned the JQ thing. So if you silence the progress output and then pipe it to JQ with a dot, you get pretty. Doesn't really matter for a list like that, but once you start getting the nested data structures, it's a very nice tool, and I would recommend it. What else can we do? We can get a list of the documents in that shopping database that you just saw, because it was syncing to this machine. So if where's that S coming from? Muscle memory, I think. We're going to go for, this is the shopping database, and it's all docs. This isn't the detail of all the docs. This is just like the placeholders. This shows you the IDs. By default, it won't expand it, but you can easily get that information with include docs. The thing I like about CouchDB is you can very often just guess what this thing should be called. And let's get this through JQ, because there's going to be a bit more of it. So there are the docs. You can see the cake and the sweets that I just added as the last things. And they got synced into the database here. So that's curl. It's very easy. You can imagine making these calls from your code using Guzzle or PHP. I've used PHP stream wrappers before, which perform really well, by the way. They're a bit of a pain to work with. Like they're not fun at development time. They're quite fun at runtime. So that's quite a good thing. The other tool that I wanted to mention, just as a slightly more humane option, is called HTTP Console. It's an NPM tool. So and what I like about that is you don't have to type the whole URL all the time. So I just HTTP console, tell it where I want to go, which is here. And then I can start just setting things up. Like I'm going to do, I think the slash was supposed to go on the beginning actually. I'm going to go to the shopping, and I'm always going to send, so you can see which headers it's going to send. Headers. You can see the headers that it's going to send. And if I say I'm working with JSON, then my headers start including this content type. I haven't got to include the URL every time. I haven't. If I work with the Cloudant IBM Bluemix's hosted CouchDB, the URL's got all the creds in it. It's like longer than my screen. So I'm not copying and pasting that, typing that all the time, which is nice. And I don't have to remember to send the header, which is also cool. I can just, so if I get that list of docs again, it's got to underscore all docs, include docs. Come on. Then you can see me getting things back, and we can start to create things. We can start to work in more detail with the stuff here. So if I'm going to create something, CouchDB is just a RESTful interface. So we use get to read, we use post to create, we use put to update, and we use delete to delete. You're shocked, I can tell. OK, so all we need to do here is send some information. I'm going to create a new item. I can't remember what wasn't on the list, so let's put eggs on the list today. And you can see there's the status code. That green line there, 201 created, means we made a new record. If I do all docs now, I'll see that record coming back. It also gives me the ID, so I can specifically fetch this thing, get that. No, that. I don't usually use my laptop keyboard. And there you can see it. So I've got the ID, I've got the item, and any other fields that I set. Also got the revision number. This is key to how we work with CouchDB. It doesn't just know the ID of the record, it knows which version we're on. You work with a RESTful interface. To do an update, you get the record, change it, and in a separate request, you put it back. So it's very easy to accidentally overwrite things. The revision thing stops that from happening. So it's like etag for databases, something like that. So I get the ID, and then if I want to change this record, I'm going to use put. Fine, we know the ID, so we're going to do put, and then paste. I need to put some data here like I did for post. So the item is going to be, we'll stick with the eggs because I can't really remember what else is in the list. And I don't get a success code, I get a 409 conflict. You can't just go around updating records in CouchDB. You have to say which version, which revision of this record you're working on. And that's how we avoid that conflict. When you try and save over a record, if I fetch the record and you fetch the record and you write a change to it and then I try and write a change to it, I would normally overwrite your change. But with the revisions, I have to say which version I think I have. And if I'm out of date, it'll get rejected. This is how we do not ever lose changes in CouchDB, even making changes in lots of different places and then synchronizing them. So what I need to do here is I need to grab this revision and add it to my data. So when I do the put and I do this, I need to add the revision field that I'm working with. And now I get the success response. Yay! Look closely at that success response. It's not a 200 OK. It's another 201 created. CouchDB has not updated my record. It's created a new document with the same ID and a new revision number that you can see here. That means that we have some sense of which revisions went before. It doesn't store the whole thing forever. There's lots of garbage collection. It's not version history. It's not Git. You can't go back in time. But it has a sense of this. It keeps tabs of the fact that there were previous revisions, which revision you think you're updating, which I think is very, very neat. This isn't the friendliest way to work with a database. I'm trying to show you my favorite tools. CouchDB also has the web-based tools that you got a little hint of when I started Apache CouchDB, and it threw up this. So this is Photon, and this is PHPMyAdmin for CouchDB, essentially. It's a really nice tool. You'll see me popping in doing a few things during the talk. So that gives you a web interface, and it kind of hides the revision remembering thing, and all the libraries will hide it as well, something that I have in my PHP library. So you can just be like, get me this version, change it, push it back, and it'll just send it. You don't really see the revision field. It will sort all of that out for you. OK, so Photon shows you what databases you have. You can view all the documents. You can edit documents here. You can create things here. You can delete things here. You can also create views and run some queries from this. You can do basically everything on CouchDB through this. You can also start replication jobs, which I'm going to talk a little bit more about in a minute. So, I've shown you CouchDB. It's a document database. It's got lovely tools. It's very easy to work with. We know about JSON. I've said how well it scales. I've said how well it performs when it works with data. It's widely used with particularly big data sets. And I feel like, yeah, we could stop there. Great database, love it, awesome. On the basis that it's 4:30, you know that I'm not actually done, don't you? CouchDB has a changes feed. You can literally get notification of anything changing on your database. Can anyone think of a use case for that? Would that be useful to you to know that something else somewhere made a change on your database, and it might be an event that you want to respond to? Does that seem like a programming model that you could maybe work with? This is so powerful, and it's here because it's the basis of how all the replication works. If you think about it, if I said to you, you need to make something where if I make a change on one storage system, it must be reflected to the other storage system. And if you think about how you would do that and how you would keep track of what you had and which changes have been made, you would end up with a simple version of CouchDB's replication protocol. very, very good. And the changes feed is needed because these two databases, or 200 databases, or however many databases it is that you have talking to one another, when something changes in one place, everything else needs to know. So the changes feed has to exist, but CouchDB exposes it to the user, and we can make our applications work off this. I use this, I'm working on a Stack Overflow dashboard where we can look at the Stack Overflow questions that have been asked for the topics that we're interested in, that we want to help people with. And if I want to work on something, I can just say, I'm going to work on this. But if I need my colleague Patrick to work on something, he's in a different time zone to me. So I just assign it to him, and he gets a Slack notification, and that all works from, there's a changes feed, oh look, there's a new assignment thing happened, and the bot goes off and processes that. The replication is incredibly powerful. I mean, you've seen it in action in the demo right at the start, and even when it's two devices replicating to the server and back, it's quite quick, it's quite performant. And the replication can be in either direction. So you don't have to sync records in both directions. You can just send all the data. And I have one setup where it's the same thing, it's the notifications thing. I don't want all of the clients to be downloading every event that's ever happened. But if something happens there, I need them to synchronize up to me. So they just push and they never pull. So it can be in either direction. It can be one-off. I quite often just replicate one of our open data sets down locally so that I can play with it, write some queries. I don't need to replicate backup or anything. This is how you back up a database. This is how you copy a database. The replication is so easy. You just set off a one-off. It can be continuous, so you've seen it running in a continuous way. And what's really interesting is, because it's just HTTP, there's nothing close here. It's an open source project. It's using a very open standards. It's using a very robust protocol. Other things can speak CouchDB replication. You've seen PouchDB, JavaScript implementation. The other thing I see in the PHP community specifically is the Drupal project has a cool feature which shipped in, I want to say 8.2, approximately 8.2. And it's that, I don't know if you've got any Drupal users, that workspace staging thing. You can put all your content together ready on a staging site and then deploy the content. That works. And you deploy the content and it doesn't overwrite the content that you already edited slightly on live from when you staged it. So if you stage some content, deploy it to live, fix a typo on live, stage some more content, push that to live, it won't overwrite your content because it's using the replication protocol that you've seen. So Drupal used that. You can replicate from Drupal to CouchDB, but you can also replicate to Drupal. Like, you don't have to have a CouchDB in the mix. A bunch of them do. Like, we have a lot of it hosted on Bluemix. And I think that's a really nice use case where they were like, yeah, we need to try and keep things in sync. And it's a really hard problem. And they started reading around like algorithms and white papers for how you would solve that problem. And then they were like, yeah, this problem's solved. And they just re-implemented the CouchDB replication protocol. So what happens if you change things in both cases? If you change things in both places, then you try and replicate. So in this case, I've done one-off replication. Two databases have been replicated. The object exists in both places. I edit it in both places. Note that my shopping list example doesn't have an edit button. Yeah, if you edit in both places, now you're in trouble. When you try and synchronize again, CouchDB will look at the replication, and unlike, let's say, Git, it won't screech to a halt and be like, help, I need a grown-up, there's a conflict. Instead, it chooses a winner. It looks at two versions, and it chooses a winner. And it is what's called a deterministic algorithm, meaning given the same two documents, it will always choose the same winner. So it doesn't like fight with itself on replication or anything. Like the same document will always win all the way through. What it does do is it keeps a record of the losing document. So that document that wasn't chosen isn't lost. You can get that back. I don't see many implementations of this, but the idea is that you could prompt the user. You know, if you go to edit a WordPress post and it says, there's an autosave newer than this version, you can do that. You can be like, well, here's your document, but do you want to look at the other one, like just in case? So it can let you know. What you do is you append conflicts equals true when you're fetching, and it gives you this array of conflicts. So you can see there I've got an underscore conflicts array with an ID in it, and I can fetch specifically that version. And have a look at it, offer it to the user, do whatever. CouchDB doesn't store these forever, but if it's been a conflict, it'll be there for a while. If it was just a document and then it got outdated because you updated the document, that previous version will be gone quite quickly. The database doesn't get huge with all these versions. If it's a conflict, it'll be around for longer because you're more likely to need it. OK. Yeah?
Can you influence the winning side in any way?
Can you influence what wins? No. If you need to influence that, then you need to keep an eye on the conflicts yourself, and then you can obviously overwrite those, choose your own winning document, switch it over. I have seen that in like one place, but actually that team then unimplemented their change because it's quite smart. Like, it's stupid, obviously. There's a machine. It has no idea what your data is or what the context is. But it looks at how many times it was updated. So if you edited it, like made one small change on one device, and you made like 5 edits on another device, it'll usually pick that one. It'll also do, like, if you worked on something a week ago, and then you made 3 edits today, it's more likely to choose the one that you just changed. So whatever you were just working with is more likely to get picked. So it's some combination of those things. Somebody somewhere decided what the number should be. And to be honest, I find it works pretty well most of the time, which is all that you need. Let's talk a little bit about the Mango queries. So Mango is supposed to be a Mongo-like query language. I'm not convinced that the people who contributed this feature to CouchDB had used MongoDB. It's got some sort of similarities, but if you know how to query MongoDB, that isn't going to help you. Some of the operators are the same, is the nicest thing I can say about this. So the idea here is that it's more like SQL. You don't have to plan ahead. Normally with CouchDB, you create views, and you can't ask questions you weren't planning to ask. You have to like limber up and describe your question and then ask it. Mango gives you the ability to do like a little bit of one-off filtering and get certain records out of the list. So you get the selector, so that's your where clause. You get the fields, which is just the list of fields that you're interested in having returning. You can do some sorting, and you can also say like, well, I've had those ones, I need the next batch. And you can also limit how many records you actually have. So I can show you a little bit on that. Here's one I made earlier. So if you have a look at this, this is a query which grabs all of the products. I'm using a different database, because you just watch me put 6 records with 1 field into a database. It's not going to make really good queries. So I've stolen a products database, which has some actual data in it. And here I've got the selector, which I said is like the where clause. So we've got where the year equals 2012. Let me tell you now, the fields are case sensitive. Just be really careful with it. OK. Guess how I learned that? OK. And the list of fields that we're interested in. So I'm just going to get the quarter, so the time period where this product was added, and also information about the product line that this belongs to. I'm only going to get 5 of them, because that's basically all you can see on a screen this size. And I'm going to make that query. So again, I'm just going to use curl, but I'm going to cheat. You don't want to watch me type this, so we'll just grab it. OK. And yeah, no, that's because you didn't let me type the file on the end. So we run that query. I've left the index in place. Rubbish. You run this query, and it will give you some results. Normally, it'll also show me I've left the index attached to the database. Normally, it says, I had to search the whole database to find this record. Go and try again. So a bit like built-in explain plan almost. If there's no index that it could use to improve the query, it will always show you a warning. So to create the index, if you look at the URL that I used here. So it's the name of the database and then /_find. If you use _explain instead, it will tell you about your query. And if you use _index, then you can create an index, which will make it faster. So that shows you, okay, so the database is products, and I'm using this particular index, which is called year, and it's an index on the year field. I'm really good at naming things. It's something I've worked on a lot. And then it gives you some more information about how many records it had to read and stuff. So we have that built in, and you can create these indexes to improve the queries. But if you are not getting an index in use, you can create one, and you can find that out because you'll get the warning, and the explain plan will help you. So that's one way to get data out of CouchDB. The other way is by using a view. Now, I'm not sure how similar views are to what you're familiar with from more relational databases, but the views are, we define the views in advance, and then we fetch data from them when we want to use them. They're quite straightforward. I'm sorry, more JavaScript. They're written in JavaScript. On the plus side, CouchDB is written in Erlang, so I think we should be grateful that they let us write them in JavaScript. My JavaScript is much better than my Erlang. They use something called MapReduce. Some of you will be familiar with MapReduce, but I'm going to recap anyway, just in case anyone either isn't or has forgotten. The output of the first step, the map step, gets stored, and that's why this performs so well. You can use views either for just filtering data. So in our example of it's a database of products, we can return all the products, some of the products. That's what we can do with the view. We can also do aggregation. So we can do totals or subtotals or averages, that kind of manipulation. With Mango, you can only do filtering. We have some geospatial stuff. I'm not talking about that today. MapReduce. So map, reduce. You do map and then you do reduce. So the map part, what we do is we work through and we look at each document. And while we're looking at that individual document, we say, is there any data here that we want to put into our view? And we make a decision about whether we should emit anything from this document. And it might be, I want to count how many articles there are in each category. And for that, we'll look at each article. And if the article is in the recipes category, we would output one value. And if the next article is in 3 different categories, we might emit 3 different values. So that article will be counted in each of those 3 categories. So we go through, we look at each document, we decide, is there anything to emit? How many things should we do? Work through, output, give some outputs of the map. What's important here is MapReduce is used on big data because we're not actually looping through each document in turn. We just need to get all the documents looked at, but we can scale that horizontally over as much compute power as you have available. You're running it on your laptop, probably just run on one core. When you're running CouchDB in a cluster, if it's big enough, it'll start using however much is available to it. And that can mean on a very big data set, this can be surprisingly quick. We store the output of the map. So if we want to know how many articles are in each category, and then we want to know how many articles are in the recipe category, we don't look at all the documents again and recalculate it again. We keep the output of the map step, and that is stored. If the documents, each of those values know which document they came from. If that document changes or is deleted, the map gets updated. If a new document is added to the database, the map gets updated just for that document. We're not rebuilding and recalculating this all the time as you are on a relational database every time you run a query. If all you want to do is filter, I only want the articles which are recipes, then you have everything you need. You can just get that by querying the view. So in this example, I've got a product. It's got some departments, it's got an in-stock flag, and it's got a date. Hopefully that was big enough for you to read, because now that's in the JSON box. I didn't try and shrink my JSON. This is a map function. It's a function. It receives a document. We emit a key and a value. I know it's JavaScript. You're all still with me. Notice that I've emitted null. So all I've done here is given a key. I don't need to emit the document because I can always fetch the documents as well as the keys they belonged to. It keeps my view smaller. If I want to create a view that only shows products that are in stock, I can look at each document, look at the in stock flag. If it's in stock, I'll add it to the view. If it's not, it just won't be there. I won't be able to fetch it. So for each document, we may or may not output or emit a value. If I want to emit for each department that this product belongs to, then I'm going to loop through that array and potentially emit multiple times. You can see I've got a few things coming out. So I might emit more values into my map than I had documents at the start. Once we've done the map, then we do the reduce. And what we do is we group all of the emitted things by key. And we say, right, you take the recipes, you take the book reviews, you take the soldering tutorials. Right, now count them. So we spread that workload out. The map is we calculate the values we're interested in, and the reduces, we combine them. We do aggregation, we do counting, or we do averages or whatever. But we can split them up by key, so we can split up the workloads. If the workload is massive, it'll get split in half and then combined again later. So that's map reduce. In the example with counting the departments, we would do exactly that. So if we've got a product that's in 3 different departments, we emit those 3 different values, but they go into different buckets, and then the reduce function just operates on what's in front of it. Again, when you've got very large data values, being able to scale out that work horizontally is what gives you the performance in CouchDB. CouchDB has reduce functions. You can write your own reduce function. You're probably doing it wrong. Not necessarily. I have written my own before. But for the most part, it has some count and something called stats, which does averages, standard deviations, and some other stuff that I don't understand. So it's got you covered for the majority of things that you want to do. Otherwise, yeah, you can take that, you can write your own reduce function. There are some really good examples in the documentation. You only need to use the reduce step where the answer isn't a subset of what was in the database. So if it was a list of products, and the answer to your question is a list of products, products in a particular department, products in stock, products added in May, then that you don't need the reduce step. You only need the reduce step if you want to count them, add them up, whatever it is. There are some really neat tricks you can do with this. You can, let me show you. I have time to just do a little bit more, just a little bit more. The views already exist, okay, good. So I'm reading my instructions, it says the views already exist. Oh. So what we have here is, this is the code for a map function. This is a view function. So again, there's a function, it accepts the document, it emits a key and value. Marvelous. So I've already created this on the database. So now you get to watch me to type the world's most impossible. I'm now regretting this choice. It's 5984, the world's most impossible URL. So this is the year view. And if you do this, all you get is how many products there are in total. Not terribly helpful. Instead, what we want to do is we could use this view to tell us, well, the key is year, so show me all of the products added in a particular year. Or sorted by year, let's do that. I need some quotes around this before I put an ampersand in. Here we go. Can you tell this happens often? Here we go. Include docs. I do want to see the details of the docs so that you can see what's going on. I do not want it to reduce. That's what's happened, is it's just counted everything. And that's an and. Let's just have a few of these. Quotes. Missing named view. Question mark, thank you. Okay. So what we have here is just the first 3 rows that matched my my view. So there's no reduce. The view contains documents. Here are the documents. How about the ones with a specific year? Now I've got to escape my quotes. Key, no, key. Now I need to escape the quotes. Here we go. Documents added in 2012. So we start to see that we can use this and filter it. But I can also use the group functions. Group equals true. And group by matching keys. So by itself, it just counts everything, turn on the group, and it can group by key. So you can use this at multiple levels. Now check out this view. This one is very advanced because it's 5 lines long. We look at the quarter field, and it contains both some quarter information and some year information. So I'm just going to pass that in JavaScript and emit a key that is an array. So the key contains the year and the quarter. I can query the view. Actually, let's just leave it grouped and grab it. Year-quarter is the name of the view. And with the grouping on, I get everything added. This is just the time period that I have data for. So I get everything added by which quarter of the year it was added and which year it belongs to. Year and quarter. How about if I wanted the data that was just year? Well, I can do that with CouchDB. I can just say, I'm only interested in this. So when you're building your views, you emit the data in decreasing sorts of significance. If you want to be able to total by year, or by quarter, or filter by those, you add it like this. You'll often see data which has keys year, month, day, hour, minute, second. And you can retrieve the records, or the averages, or the sums, by whatever unit you're interested in, all from a single view. So when you're adding a document, you're not recalculating all those different views, you just need one, and it allows you to do totaling and sorting on the back of that. I think it's very elegant. Some of you might be bored. It is late in the day. So anyway, CouchDB, amazing, amazing. I really enjoy this technology. I think it's fun. Helpfully, I obviously have a hosted version to play with, but it's open source, so I'm running it locally, and most of the time I'm playing with the local version. The CouchDB 2 and the hosted cloud options are basically the same. They're totally not. The engineers will be angry, but I haven't found any differences that matter to me as a developer yet. So that's my story. Working with CouchDB brought me immediately into contact with PouchDB. A lot of the users of CouchDB are people building these progressive web apps, looking at these sorts of problems, trying to make applications that are robust for all sorts of use cases. Some of them in places where you might expect limited connections, some of them not so much. So all of it's open source. All of these communities are very accessible as a contributor, as well as having great docs, welcoming attitude, they'll answer your questions. It's also really easy to get started with, and I hope I showed that with my JavaScript example. I started that project knowing that my colleagues could build this, and they were more likely to help me if I'd tried first, right? Because everyone's busy. And then I tried, and then it was done. So they didn't have to help me at all. It is approachable. This is stuff that I think we should be thinking about in our own applications. If you're not already being asked for these web features, you will be. When it's required that the catalog works offline, even if the checkout process doesn't, this is where you're going to come for those sorts of technologies, when you need to solve those sorts of problems. I have a few minutes for questions. Let me just run you through the links that I have here for your enjoyment. The first one is the feedback link. This conference is using Joined In. It's a tool intended to give feedback for the speakers. All of the speakers massively appreciate it if you have time to write a few words for them. let them know what did and didn't work, otherwise you'll be stuck with terrible talks forever. Some resources for you, my own blog. I write a lot about this and other technologies, so it's a good place to find slide decks that I've done and also read about stuff. There's the link to the GitHub repo of the shopping list demo that I showed you today. The link underneath it is some more complete shopping list examples that my team have built. Now, the code for those don't fit on a slide, but if you are building with React, Preact, Polymer, Vue, Ember, or you want a more sophisticated, simple JavaScript front end, or if the people you work with use those tools, don't look so horrified, then there are some examples there that you can show them that hopefully will get them started for how the moving parts would work. Offlinefirst.org is a thriving community with events here in Europe as well as in North America, and some really good advice for the different technologies that you can use. There are alternatives to what I've shown you. And I've got to mention Hoodie. Hoodie is a framework that aims to get you started very quickly with this stuff, and it handles some of the issues that I have skated over, such as working with multiple users and logging in and those sorts of things. So if you're building this for production, once you get past the let's build a toy shopping list version, that would be really helpful. Okay, does anyone have a question? This is fine. I'm really happy to just give up and sit down now. That's okay. In that case, I will just say that I'm around. I'm planning to be at the event this evening as well, so I'm happy to chat in a more informal way. And thanks for coming. Thanks for staying awake.